Howdy students. In previous videos, I talked about how climate change can be thought of as a response to an energy imbalance that's imposed on the planet. In this video, we're going to quantify how humans are perturbing the Earth's energy balance, thereby changing the climate. Let's begin with greenhouse gases. In Chapter 5, you learned that carbon dioxide is increasing. This produces an energy imbalance, which we quantify using the concept of radiative forcing discussed in the last video. Radiative forcings are changes and therefore have to be calculated with respect to a reference period. This is similar to temperature anomalies, which also have to be calculated with respect to a reference. The values in the book and this video come from the 2021 IPCC report, which use a reference period of 1750 before the Industrial Revolution. Carbon dioxide has increased by about 130 parts per million since then, which corresponds to a radiative forcing of 2.15 watts per square meter. Just to be clear what this means, if we increase carbon dioxide from about 280 parts per million, the pre-industrial value, to about 408 parts per million, the value in 2018, and we don't let the temperature of the planet respond, then the increase in carbon dioxide will generate an energy imbalance for the planet of 2.15 watts per square meter. This is the radiative forcing. In response, the planet will warm up, which will erase the energy imbalance, and the planet will reestablish energy balance at a warmer temperature. That's climate change. We also know that other gases are also changing, such as methane. The increase in methane from about 0.8 parts per million in pre-industrial times to 1.8 parts per million in the 2010s generates a radiative forcing of 0.54 watts per square meter. Now, the advantage of using radiative forcing here is that it allows us to express diverse changes to the climate system using a common metric. For example, we can quantitatively compare the climate impact of a 130 part per million increase in carbon dioxide to a 1 part per million increase in methane. We can now look at the radiative forcings of all the greenhouse gases. Carbon dioxide is the most important greenhouse gas, making up about 2/3 of the total greenhouse gas forcing. Methane is in second place. Other greenhouse gases that are increasing in the atmosphere include the halocarbons, man-made chemicals used in refrigerators, air conditioners, and industrial processes. Ozone is an important molecule that blocks dangerous ultraviolet radiation from the sun from reaching the surface. Ozone is also one of the primary components of air pollution. That's getting worse over much of the world, meaning that lower atmospheric ozone is increasing, thereby generating a positive radiative forcing. Totaling these up, the total radiative forcing from greenhouse gases is 3.5 watts per square meter. The next category of human influence on the climate system are aerosols, which are particles so small they do not fall under the force of gravity, but remain suspended in the atmosphere for days or weeks.
This animation shows the distribution of aerosols over the Earth. Blue shows sea salt aerosols, which are formed when strong winds lift droplets of water into the air and the water evaporates, leaving a salt particle. Red shows dust aerosols, which are lifted from the ground primarily in the big deserts of the world, like the Sahara. This dust can be transported long distances. Green shows carbon aerosols, which are primarily formed when biomass is burned. You can see these aerosols being emitted from regions where biomass burning is prevalent, such as over Africa and South America. White aerosols are sulfate aerosols, which form when fossil fuels containing sulfur impurities are burned. When this happens, the sulfur is released to the atmosphere with the other products of combustion. Once in the atmosphere, the sulfur gases react with atmospheric water vapor to form highly reactive small liquid droplets known as sulfate aerosols. Most of the sulfate aerosols are located in regions with a lot of manufacturing and lax air quality standards, places like China and India.
While aerosols vary in composition and in impact on the climate, the dominant impact of aerosols is to reflect solar radiation back to space. Human activities have been increasing the amount of aerosols in the atmosphere, causing the planet's reflectivity to increase. This increases the albedo of the planet, leading to cooling of the climate system. Scientists estimate the radiative forcing from aerosols is therefore negative, with a magnitude of minus 0.3 watts per square meter. Because this is the direct impact on albedo from aerosols, this is referred to as the aerosol direct effect. However, aerosols also have an indirect effect on the climate, whereby aerosols influence the climate by altering clouds. There are several ways that this can occur. One of the clearest mechanisms is by altering the number of particles in a cloud. Cloud particles form when water condenses onto pre-existing aerosols. It is the number of these aerosols in an air mass, therefore, that determines how many cloud particles are found in a cloud. When humans add aerosols to the atmosphere, they increase the number of droplets making up clouds that form in this air. But the total liquid water contained in the cloud is fixed. Thus, each droplet has less water and is therefore smaller. It turns out that a cloud containing smaller droplets is more reflective than one containing large droplets. Thus, as humans add aerosols to the atmosphere, cloud particles get smaller and clouds get more reflective. This also increases the albedo of the planet and generates an additional negative radiative forcing, which is referred to as the aerosol indirect effect. This number is hard to measure, but our best estimate is that it is about minus 0.7 watts per square meter. To summarize, greenhouse gases produce a total radiative forcing of 3.5 watts per square meter. Aerosols produce a radiative forcing of minus 1 watt per square meter. The other small radiative forcers, which we did not discuss, sum to about 0. This generates a total radiative forcing from all human activities of 2.5 watts per square meter. You should remember this value of total radiative forcing for the exam. Let's tie this back to our favorite equation. Humans are adding greenhouse gases to our atmosphere, which increases the number of layers and warms the climate. At the same time, humans are adding aerosols to the atmosphere, which increases the albedo and cools the climate. More quantitatively, the warming from greenhouse gases is larger than the cooling from aerosols, so the net impact of human activities is to warm the climate. But aerosols offset about 1/3 of the warming from greenhouse gases. That's a good number to remember. Aerosols are also one of the primary components of air pollution, which is a terrible public health problem that kills millions of people every year worldwide, including tens of thousands of Americans. As some of the most polluted places in the world clean up the air, which would deliver tremendous benefits for public health, it will make climate change worse by reducing the offsetting power of aerosols. This is one of the many tricky aspects of the climate problem, which we'll get back to in Chapter 14. And now, your moment of dog.